Hello everyone, I'm academician Dr. Lilia. Welcome to Science and Me YouTube channel. The mission of my channel is to introduce you to popular science and to create a popular science encyclopedia on YouTube. We are back with an interesting popular science video. I would be very happy if you support me by subscribing to my channel and writing a comment. If you are ready, let's start the video. Self-driving cars are vehicles that can navigate and operate without human input. Self-driving cars use a combination of sensors, cameras, radar, and artificial intelligence, AI, to travel between destinations without a human operator. The technology behind self-driving cars is complex, but it can be broken down into three main components. Sensors. Self-driving cars use a variety of sensors to perceive their surroundings, including cameras, radar, lidar, and ultrasonic sensors. Cameras provide visual information. Radar can detect objects through fog and rain. Lidar creates high-resolution 3D maps of the environment, and ultrasonic sensors can detect nearby objects at close range. These sensors include lidar, light detection and ranging. Lidar sensors use lasers to create detailed 3D maps of the car's surroundings. They can accurately detect objects and their distances, making them crucial for obstacle avoidance. Radar. Radar sensors use radio waves to detect objects and their velocities. They are effective in various weather conditions and are often used for longer-range object detection. Radar can detect objects that are too far away or too small to be seen by cameras, such as other vehicles and pedestrians. Software. The software in a self-driving car is responsible for processing sensor data and making decisions about how to move the car. The software uses a variety of algorithms, including machine learning and computer vision, to identify objects in the car's surroundings and predict their behavior. Self-driving car software uses the data from the sensors to create a real-time model of the surrounding environment, identify and track other vehicles and objects, and make decisions about how to navigate safely. The software also includes machine learning algorithms that allow the car to learn from its experiences and improve its performance over time. This software is powered by AI, which allows the car to learn and adapt to new situations. Hardware. Self-driving cars require powerful hardware to run the complex software and process the data from the sensors. This typically includes high-performance processors, graphics processing units, GPUs, and specialized hardware for artificial intelligence, AI. Cameras. Cameras provide visual data that is processed by computer vision algorithms to identify and track objects, read road signs, and detect lane markings. Cameras are used to detect other vehicles, pedestrians, traffic lights, and road signs. Ultrasonic sensors. These sensors are used for short-range object detection and are often found on the bumpers of the vehicle to assist with parking and low-speed maneuvering. Actuators. Actuators are the components that control the car's movement. This includes the steering wheel, brakes, and accelerator. The software in the self-driving car sends signals to the actuators to control the car's movement. GPS, Global Positioning System. GPS is used to provide the vehicle's location and help with navigation. However, it is not precise enough on its own for autonomous driving and is usually combined with other sensors. Self-driving cars will be able to communicate with each other and with infrastructure, such as traffic lights and road signs, to coordinate navigation and improve mapping and localization. Autonomous vehicles rely on high-definition maps for accurate positioning. They compare the real-time sensor data with the pre-existing maps to determine their exact location on the road. Simultaneous localization and mapping, SLAM, techniques are often used to achieve this. Control systems. Sophisticated control systems manage the vehicle's acceleration, braking, and steering. These systems use the sensor data and algorithms to make real-time decisions about how the car should behave to reach its destination safely. Computer vision is a field of computer science that deals with the development of algorithms that can understand and interpret images and videos. Self-driving cars use computer vision to identify objects on the road and to track their movement. Artificial intelligence, AI, and machine learning. AI and machine learning algorithms process the data from sensors, making sense of the environment and making driving decisions. Deep learning models are used for tasks like object detection, lane detection, and path planning. Machine learning is a type of AI that allows computers to learn from data without being explicitly programmed. Self-driving cars use machine learning to learn how to identify objects on the road, such as other vehicles, pedestrians, and traffic signs. Deep learning is a type of machine learning that uses artificial neural networks to learn from data. Artificial neural networks are inspired by the human brain, and they are able to learn complex patterns from data. Self-driving cars use deep learning to learn how to navigate the road safely and efficiently. Connectivity. Self-driving cars often rely on communication with other vehicles, V2V, and infrastructure, V2I, to enhance safety and traffic management. This can help in scenarios where the car's sensors may have limited visibility, such as around corners or over hills. Redundancy and safety systems. Autonomous vehicles are designed with redundancy in mind to ensure safety. Multiple sensors, control systems, and backup systems are included to prevent failures. If a component fails, the vehicle should be able to safely pull over or come to a stop. Human-machine interface, HMI. Self-driving cars have interfaces that allow human passengers to interact with the vehicle and monitor its status. These interfaces may include touch screens, voice commands, or even augmented reality displays. Self-driving cars work by following these steps. Perceive the surroundings. The car's sensors collect data about the surrounding environment. Interpret the data. The car's software uses algorithms to interpret the sensor data and identify objects in the car's surroundings. Make decisions. The car's software uses AI to make decisions about how to move the car, such as whether to accelerate, brake, or turn. Control the vehicle. The car's software sends commands to the car's actuators, such as the steering wheel, brakes, and accelerator, to move the car according to the decisions it has made. Challenges. Self-driving cars are still under development, and there are a number of challenges that need to be addressed before they can be widely deployed. These challenges include safety. Self-driving cars must be able to safely navigate in a variety of conditions, including in bad weather and in heavy traffic. Legislation. Governments need to develop regulations to govern the use of self-driving cars. Public acceptance. The public needs to be convinced that self-driving cars are safe and reliable before they are widely adopted. Despite the challenges, self-driving cars have the potential to revolutionize transportation. They could make roads safer and more efficient, and they could provide new mobility options for people who are unable to drive themselves. Self-driving cars are expected to be much safer than human-driven cars. This is because they are not susceptible to human error, such as drunk driving, distracted driving, and fatigue driving. Efficiency. Self-driving cars can communicate with each other and with traffic infrastructure to optimize traffic flow. This could lead to reduced congestion and shorter travel times. Accessibility. Self-driving cars could make transportation more accessible to people with disabilities and to people who live in rural areas. However, there are also some challenges that need to be addressed before self-driving cars can be widely deployed. These challenges include cost. Self-driving cars are currently very expensive to develop and manufacture. This is because they require a lot of sophisticated hardware and software. Regulation. Governments need to develop regulations for the safe operation of self-driving cars. These regulations need to address issues such as liability and insurance. Public acceptance. The public needs to be willing to trust self-driving cars. This may take some time, as people are used to being in control of their own vehicles. Regulatory compliance. Autonomous vehicles must meet strict safety and regulatory standards. Companies developing self-driving cars work closely with regulatory bodies to ensure their vehicles comply with existing laws and safety standards. Testing and simulation. Extensive testing is conducted, both in real-world conditions and through simulation, to validate the safety and performance of self-driving systems. Millions of miles of testing are often performed before autonomous vehicles are allowed on public roads. Cybersecurity. Self-driving cars are vulnerable to cyberattacks, so robust cybersecurity measures are essential to protect the vehicle's systems from unauthorized access and manipulation. Overall, the development of self-driving cars is a complex and interdisciplinary effort, involving expertise in robotics, computer science, artificial intelligence, automotive engineering, and more. As technology advances and regulatory frameworks evolve, self-driving cars are expected to become more common on our roads, potentially revolutionizing the way we think about transportation.